Okay, here's the discussion board question that I posed related to the senior breakfast problem, where you're looking for f of x. In this case, it's the number of students accommodated by x, which is a certain amount of tables. And the question is this an explicit or is it a recurrence relation? And the answer is explicit, because nowhere in this equation is it asking you to evaluate a previous output, okay, or use a previous output, or any output for that matter, because there's no f. Okay, so now we just need to figure out if it is the correct explicit equation. So let's take a look. Okay, this should look familiar. This is the configuration for one table and accommodating 6 students. Remember that we want one person at each end of the table, and then for every table on opposite sides, we're going to have 2 people. And so here's for 2 tables, there's going to be 10, because you have, again, same configuration, 2 people on opposite ends, and then for each table on either side is 2. So I highlighted it so that you can see that the previous output, or the previous number of students, is going to be related to the number of students that there will be if you add another table. So I'm taking the previous and then adding another 4 because I'm adding another table. So if I add 4 students for every table I add, I end up adding 4 here, and it grows by a term of 4. Okay, so this may not help you understand how to relate 7 to output 30 and 6 to output 26 and so on, but if you do rewrite these outputs in expanded form so that you can see the output representing the recurrence, then that might make it a little easier for you to understand the structure and then be able to then write an explicit equation or a general form to allow you to find the output, which is the number of students for a certain amount of tables. Okay, so we know that to get 10, we take the previous and then we add 4. To get 14, we take the previous, right? To get 14, we get the previous, and then we add another 4, and then here we take the previous and we add another 4. And so now you see a repeated structure, which will help you generalize the equation to help you come up with the explicit. So here there are 3 terms of 4. You can predict the next time there's going to be 4 terms of 4, and then 5 terms of 4, and then 6 terms of 4. So we show that using multiplication because those are repeated terms. Okay, so I just simplify this just a little bit so that I don't have to expand it too far. Okay, so and then you can see that 1 being added because it's growing by 1 term of 4. Okay, so now we can see that there's always going to be a term of 6, and there's always going to be terms of 4. So in our explicit, we're going to have those as constants. What doesn't stay constant is the number of terms of 4 you're going to have. So now we can look and take a look at how the input relates to that number of terms of 4. Okay? And so how does 7 and 6 relate? How do 6 and 5 relate? Well, the number of terms of 4 is 1 less than the actual number of tables. Right, let me say that again. The number of terms of 4 is actually 1 less than the number of tables, right? 6 is 1 less than 7, 5 is 1 less than 6, and so on. That's repeated. That's a repeated structure. So what we come up with then is an explicit equation that has the 2 repeated terms, but we know the 4 is going to be repeated a certain number of times. And how many number of times? 1 less than the input, or the number of tables. Okay, so this is a correct explicit equation because it will allow you to calculate the number of students depending on how many tables you have, if you're going to configure the tables like that. Okay. Okay, and another thing I wanted to add is just that you can simplify this. And what's nice about if you simplify it, then we know that no matter how you got your explicit equation, you can compare each other's work because there's only one simplified answer. So we can simplify this by just doing the indicated operations. Multiplication first, or parentheses first, but you can't do anything in there. So you're going to multiply the 4 and distribute, and you end up with 6 plus 4x minus 4 because you distribute the 4. And then when you simplify this, you can combine like terms, and 6 minus 4 is 2, and then that 4x is left at the tail end. Okay, and then that's simplified. So it's fine if you can get this far and not simplify it, but when you're comparing your work with others, or if you want to compare your answer with the answer that I give you, it's important that you know how to simplify.